Good morning. Is this still morning? Yeah. So morning, afternoon, depending on where you are, it might be evening. So good evening. Yeah. I'm David. Not the carbon copy of David, but the open copy of David. So yeah, the topic accidental DevOps. It's primarily meant to tell us what it entails to be DevOps, what you think about when you think of DevOps. Some wake up and say, oh yeah, today I'm going to be a DevOps engineer. Is there such a thing as a DevOps engineer? Or, I know we have questions. The aim of this talk is try to address some of these questions and misconceptions we have when we hear DevOps and what we think we know about DevOps. Yeah, so for me, DevOps was not what I was born into. I didn't wake up knowing what it took to be DevOps. So the accidental DevOps is more or less a tale of my journey to being where I am today. So, yeah, so you know all this. If I was a gopher, I think that's how I would look. So for those who know Golang, gophers are the mascot, and I think that's how I would look if I was a gopher. Yeah, currently the engineering manager for DevOps at OP, and yeah, it's quite interesting, a place to work, and a lot of awesome things happen there. So, not working. Point click. Oh yeah, awesome. My fonts colors are not clear, but in the beginning I started as a systems engineer. I deployed softwares others wrote. That was my life. So I woke up, had to learn how Microsoft servers worked, deployed them, woke up, had to learn how Symantec antivirus worked, went to a client side, deployed it. That was my life on a daily basis, and all was well and good. And I moved on to somewhere else where I became the infrastructure engineer. And this time around, I worked with those who wrote the software, but I still deployed. That was still my everyday work. So this time around, my deployment changed from deploying the finished software, reading manuals, to working with people who wrote this software on a daily basis to deploy it. And then another shift occurred to where I started participating actively in the writing of the software. Now, I still don't write as much as the core software engineer, but I still participated in the software writing itself, participated in every single aspect of the ideation phase to when the end user took hold of what we have been writing. So that was what I was doing, or what I am still doing now as a DevOps engineer. Now, I said DevOps engineer loosely. I'll explain in a few minutes. Now, going forward, yeah, the caption there is ... engineer. I'll still be an engineer going forward, no matter what term we come up with in the nearest future. Now, DevOps looks like a buzzword and all. Whatever we come up with in future, I'll still be an engineer. At the core of everything I do is engineering. Of course, that's who I am and who I would always be. So when we say DevOps engineer, technically there's no such thing as a DevOps engineer. My job title says DevOps engineer, right? But there is no such thing as a DevOps engineer, because what DevOps is engineering itself. Now, if you're familiar with the base definition of engineering, you probably would have heard something like use scientific tools and method to achieve goals, or use tools. DevOps is tools. The carbon copy of David mentioned tools are important. Now, when you are doing DevOps, you're going to either use tools someone wrote or tools you write. It's key to note that it's not a mindset of, oh yeah, I'm a DevOps engineer. DevOps engineer, typically saying you're an engineer. That's what you are saying, because DevOps is thinking about a problem, finding a solution to it, either with tools that exist or tools you would write. That's what DevOps is. And where the cultural shift comes in is previously we used to have a case where others wrote, you just used. You were the consumer, even the infrastructure engineer. You didn't write the software for the Cisco server you used. You didn't write the Microsoft Server 2016 you used. But when you came to a cultural shift, you started writing the softwares you used, writing pipelines. We're somewhat familiar with the term pipeline when it comes to DevOps. You wrote those pipelines. When Microsoft or AWS gave you the tools, they didn't define what you would use it for, but you wrote what you would use it for. So either you use code deploy, AWS pipelines, Azure DevOps, whatever you use, you wrote it. They gave you a template, you modified it. That writing, that modification is part of what you would keep on doing in this cultural shift and in this transitioning that we are working with. And someone said that no matter how you look at every situation, the whole DevOps condition we are in now, no matter how you look at it, it's always a people problem. People came up with the mindset that we can't live like this, we can't continue working like this, it's not efficient for us, and people thought of a next step. We thought of a collaboration, we thought of a case where everyone knew what the other person did. Bill Kennedy, well, he's not the originator of this quote, but he uses the term mechanical sympathy a lot. So what he meant there is when you're writing code, you are aware of what kind of hardware it will run on. You are aware of how much memory, or you have an idea of how much memory it will take. So when your infrastructure guy takes a look at your code, he has an idea of how many instances to provision, or how much load will be necessary to provision before your application crashes to production. Therein, in that situation, everyone was somewhat aware of what was going on in section A and section B. So however you choose to define DevOps, it's still me and you, everyone in this room, being DevOps culture, being DevOps engineers, and being SREs or whatever title you choose to give to it, but we all work together to make the system function. Yeah, so when you choose to adopt this mindset, it's important to change how you think. It's important to know that what used to work for you might not necessarily work in this new sector. So I wake up and I remember that, oh yeah, to deploy an antivirus software, once upon a time it was as easy as buying and deploying. It still works that way, but when you have an application that's just the antivirus software would not prevent you from being hacked. Of course, your server is still safe, but your application, is it safe on that same safe server? So I have the antivirus software running on it now, but I deployed my banking application to it. The antivirus will not protect me from someone on the internet trying to hack into my system. So security goes beyond the software I buy at the market. It goes to as deep as what I write into my infrastructure or what I write into my code. So there's a cross-site request scripting. So if you are aware of that as the infrastructure engineer, you would know that, okay, yes, I should set some rules in place. I should maybe set some cookie expirations in some section or the other. But if you had left it to the guy who wrote the software and say, that's their business, I know my infrastructure, I've set up the antivirus server, we can never be hacked. If you're hacked, you'll be fired. So it's seriously not just a one-man problem, it's all our problems. And so in this whole methodology or new mindset, you always have to adapt. I knew it yesterday, worked yesterday, you will not work tomorrow. So you always have to adapt, you always have to be agile, whether you are the best or not. You always have to be agile, you have to be willing to do something different from how you did it yesterday. Now I'm sure everyone here knows one thing or the other. You probably know how to write some scripts in the terminal, probably know how to maybe write some code in Java, any language you like, but if something happens tomorrow and your boss tells you, we're not using Java today, we're using Python and we need it in production next week, you wouldn't quit your job immediately. You think, how do I modify? How do I adapt? It's this agility that's always going to be necessary. In DevOps, agility is key. One time ago, not too long in our history, everyone loved virtual machines. They were the in thing. Your organization promoted you for knowing how to deploy virtual machines. But today, that is not the same scenario. The organization will look at it like, oh yeah, we know that's stale. But what can you do today? So if you were having some certifications, say VMware certifications, and you were the expert, when you move into this culture, you're no longer the expert, you are a lifelong student. I consider myself a lifelong student. I don't know all. Positions aside or titles aside, I am a student at the core of everything I do. I don't assume I know more than anyone in this room or more than anyone anywhere I meet, because where we are is where you keep learning and relearning. From the whole infrastructure perspective, your bare metal servers to Kubernetes, there will be something else that comes after. We're already familiar with the whole serverless construct and say function as a service. Something else will still come after. As long as humans exist, there will be evolution. You always have to keep a mind open for that evolution to come and be willing to learn. So I would use OP as a case study for a typical DevOps move. You know OP or you don't know OP. I'm not here to talk about OP, I'm here to talk about engineering as a whole. So what we had at that point in time, there were the buzzwords of financial inclusion for the unbanked, and when that was used, you at the back, you think, what does that mean to me? Does it mean that I were working on the website? Does it mean we're building a mobile app? To us, that was what was important. There was no clear definition as to, yeah, this is what we're building, and this is how you're going to get it. Then even when there were meetings held to say, this is what we're building, you had started building, and someone comes to say, oh no, this is not working. And you're like, we have written this, we've written that. You have to rewrite it. In any DevOps sphere, whether your company is big or small, you have cases where you have to re-architect things you had written. Your best practices will have to change to accommodate new needs. And that was our case at this point. So at this very stage, it was still a case of, yeah, we had no idea of whether to go left or right. And we had a few customers. We didn't want these customers to change their minds if the product wasn't working. For the engineering team, it was, okay, we have a small product that's working. We had a few engineers who knew the meat of everything that was happening, and a few feature request change. So all these were things that we coped with. We were happy. We woke up, slept, and everything was fine. In fact, our full infrastructure was more or less something like that. You had a single user coming, your load balancer, your EC2 instances, your DB, and then, the basic CRUD was what we had. Everything was going smoothly. You could wake up, had a few test servers here and there, no problem. Deployment was always not necessarily something you do today. You can deploy it every Friday if you will, or deploy every other Friday, because we didn't have many changes to make. So we were stable. For engineers, we were stable. We slept as long as we wanted, resumed as long as we could afford it, because the system didn't come under heavy scrutiny or heavy load. But then you had some business guys make some wise decisions, and more customers suddenly realized that you had a service running, and to you, your perfect plan no longer works. Your perfect infrastructure starts failing. You start seeing things like go routine spike. For those who know what that means, basically in Java, that is similar to what you have when you have a heap memory overflow. So some good code suddenly started having issues. We wrote it and we thought, yeah, when a few 100,000 people come, we'll be fine. When a million come, we'll be fine. But when a million came, we were not fine. The infrastructure we thought was perfect wasn't perfect. We now had more crashes than before. It was now a case of, I thought we were good DevOps engineers. I thought we wrote good hardware. I thought our pipeline was fine. The pipeline wasn't fine. It was fine when we did 1 or 2 deployments per week. But when we had to start doing as many as 3 deployments a week or even more, you suddenly realize that, wait, we were not built for this load. We now had more engineers who had to push their code every other second, and you had to build pipelines that could withstand that load. Earlier on, we started with, say, GitLab, and it was fine. And when we scaled up, we found some problems there that made us move to Jenkins, but we had to think of how to handle everything better. So engineering is always going to be at the core of what you do. There would always be problems. I mean, that's what we thrive on. Each and every person here is trying to solve a problem. So there will always be a problem. Don't think your system is perfect. So we didn't have a perfect system, and we were going to build. So I said here that more bugs appeared in the code, yeah, because of more people now use it. So it now seems like, yeah, we now have buffer overflow, but from our test, it was fine. Your test did not factor in 2 million users simultaneously coming to that service. So the QA person tested some parts and she said it was fine. Your code tested and your code came back with pass. You also saw the beautiful green until you went to production before you realized that there were bugs in your code. So for the engineering team, we had some rethinking to do. We had some re-engineering to do because we thought we had done a perfect job, but we had to change some things. So we had to basically increase our performance. And now increasing performance meant your security had to be standard. In the early days of OP, what you had was a website. There was no mobile app. You went to the website, performed some basic transactions, and you were fine. I'm sure maybe one person or nobody in this room knew OP at that website stage. That's what it was. So at that stage, we were fine, we were sleeping better, or we thought we were okay, but that all changed with more users. So it meant that engineering had to factor in more security into what we were doing. We had to become more stable, fix bugs faster. And fixing bugs faster meant that when a programmer finishes writing a bug fix, he had to go to production as soon as possible. We thought it was not a case of waiting till next week Friday anymore because that wasn't scalable. If it was a security fix, you wouldn't wait till Friday to fix that security loophole. So we had to increase how much we deployed and how much time it took for us to fix. And with that also came some more issues. So now we have more users, and some users are complaining about transactions failing, and you're like, okay, what failed? Initially, we couldn't answer that question. So we had to improve our code, log more things, even as far as create some form of journal to say that our transaction starts at point A, it moves to point B, it moves to point C, before the user gets the final result. So for each time a user clicked on a button on the app and got a feedback, before the user saw that feedback, we had known that that feedback was what they would get based on what had happened. So at this phase in time, it became clear that improving the system wasn't a one-off process. It was something you did on a daily basis. So I built a pipeline that allows code to be built and deployed. How long does it take for that pipeline to run? Yeah, but funny story, our pipelines used to take as long as 45 minutes at some point in time. So the guy pushed and waited 45 minutes, and you ask, what's wrong? They say, my code is building, and you cannot fault him. His code was building. You check the pipelines and you saw that it was building. So how would you prevent such a thing? How would you change such a situation? Now, I spoke with one of our colleagues here, and he had, in fact, I allowed him to look at the pipeline. I complained, and he looked at the pipeline and said, why are your images this large? We used containers, so why are your images this large? And I said, oh yeah, we use this variant of Linux and all, and said, why not use multi-stage builds? And I'm like, okay, multi-stage build, how does that work? He explained. When we did multi-stage builds, and then in AWS, there's something called image caching. We applied image caching, our build time, in fact, took a deep dive, and suddenly productivity increased. You could attend to more users. Now, this is not to say that tools were not involved, but it was more of the people I got to interact with than the tools. The tools were there. I mean, image caching was there from as long as AWS had tried to implement, say, ECS, but I wasn't using it. So I spoke with someone. I didn't assume I knew it. I spoke with someone, and then we came up with a solution that reduced build time magically, I must say. So we are familiar with all the whole DevOps is development and operations, but at the heart of everything you see here is agility. Irrespective of how you look at it or how beautiful anybody paints it, agility is at the core of everything you will do, either as a DevOps engineer, SRE, or anything you will decide to do in the DevOps sphere. It is your agile practices that would improve your system. You cannot work on that static assumptions that your system is fine, you've built the best system. AWS hasn't built the best system, they are building the best system. It hasn't ended there. And I'm sure for every single one of us, that's how our processes would go. So here we had moved to a stage where it wasn't just programmers doing the work anymore, it was now programmers wrote codes that they knew how it would work on infrastructure. The SRE guys understood how the code worked well enough to provision infrastructure for the code. Yeah, so we built and then we scaled. We had more customers, we had more users, we had more transactions, and at that stage it was a case of good engineering to sustain the business. Now, the core of all the engineering, of all the learning, was that we had to learn a lot. We had to learn a lot. I mean, we had to learn how to build systems that withstood crashes. There were crashes, believe me, there were a lot of crashes. We had to build systems that could withstand these crashes. Someone asked a security question or a backup question, how did you handle backup? We are also heavily based on AWS, and we ensured that, yes, we leverage AWS features as much as possible. I'm not hoping that AWS crashes tomorrow. If they crash, of course, we will sue for millions of dollars. If we don't hope they crash, we are relying on the 99.9% SLO for our own business. So that's how it cascades down. In AWS, some engineers came up and they had an SLO and SLA telling you that the system will be up for X amount of time. You as a DevOps engineer or an SRE, you are depending on the 99% uptime to guarantee your users a 90% uptime as well. It is your responsibility to make sure that you are able to trickle down whatever responsibility to the end user and say that, oh yeah, I can guarantee that my system is going to be fine 80% of the time. You are being pessimistic with your timelines and your own SLAs and SLOs to make sure that your system still works. So, in the beginning as well, we never wrote, say, some monitoring tools. We relied heavily on CloudWatch. And at some point, CloudWatch didn't give us what we wanted. We had to move to, say, use Prometheus to get some more metrics, use, say, maybe a tool like Loki to get more log data. And fortunately, say maybe last year, AWS brought out CloudWatch Insights, which improved our usage of CloudWatch. But before then, CloudWatch was not the go-to guy when something went wrong. He had a lot, but he didn't have everything that we needed. So we had to learn to build something else or use something else. And we had to learn the craft. I put the craft of instrumentation. Now, instrumentation is basically saying that whatever code I have running, I have some extra code to tell me what is happening in my program as it runs. So it could be logging information, or you could say metrics. So for every time someone tries an OTP and or tries to get an OTP and it doesn't deliver, I instrument my code to say count somewhere that this is the number of failed OTPs. Those are part of instrumentations. Now your business case may be different, or your use case may be different, but you have to learn that craft. And we got to a stage too, where we now had more than one server, or more than one service, servicing the entire request. You're familiar with the fact that in OPE you have something like OBOS, OWealth, or whatever you may have. All these O's were different services on their own. And so if I did an O food transaction, what happened? Was it a failure at the OPE end or at the O food end, or what happened in between? So we had to implement tracing, what you call tracing, to get what happened at each stage. In the beginning, it wasn't something we needed. But as the business grew, we needed something to give us more visibility and, say, more observability. So that was something we had to learn to do. So basically, we had to learn to relearn. We had to learn to do things better. We had to learn to improve the business. We had to learn, and I am still learning. I am a lifelong student in this entire DevOps field, and we would continuously learn to improve our systems. Now, in all the talks I ensured I didn't talk about, say, tools, or I at least talked about them minimally. Now, in the beginning, we had a very few set of tools that served us perfectly. I mean, we were fine. We had, say, your GitLab, AWS, and the Golang, Kotlin, and we were just grooving and scaling along. But then we moved on, and as we got inter-process communications, things like gRPC popped up. And if you didn't know gRPC, you had to learn gRPC. If you didn't know Prometheus, you had to learn Prometheus. And Terraform also became our friend. At this stage, we had a few servers, so it wasn't necessary to write some infrastructure as code. But then we moved on and had to implement some things. In fact, part of the requirements for, say, a PCI certification is that you have a documentation of your infrastructure. So we had to look for something that documented infrastructure for us. And then this is what the current OP looks like. You can see that at each stage, the tools were increasing. We didn't wake up using everything there. They were not necessary at the beginning. But as your business grows and as your practice grows, you will use some more tools. Learn to find the best tools that do the job for you. Don't wake up as someone in, say, the DevOps field and you want to learn the tools first. Learn the business, learn the need, and learn to engineer solutions to that problem your organization has. Don't learn the tools, then you come back and your organization doesn't need them. Or wherever you need to doesn't need them. So learn what they have as a problem and learn how to solve the problem. Yeah, so in summary, for DevOps as a whole, it's what you love that it has to be. Don't come into DevOps with the mindset that, oh yeah, it's the hot thing now. What happens when it's no longer hot? What happens when that money you think you're going to get, you don't get it? Or when your boss wants you to do DevOps, project management, and sales. Learn to do what you love. It has to be the core of your life. Now, so in my own summary, I'll tell you that DevOps is deliberate. Irrespective of how you enter DevOps, whether you woke up and felt like today I don't feel like doing anything, I'll be a DevOps engineer. It is a deliberate act. Now, whether your organization is shifting, it's also a deliberate act. I like how the carbon copy of David put it. His organization wanted something better. They wanted an agile business. They wanted to deliver to their customers faster. So they adopted an approach to it. At that point, there was nothing like DevOps engineer, or am I right? Yes, so there was no DevOps engineer or SRE at their company, but the organizational change allowed them to adopt practices that led them to scale faster, deliver faster, gain more customers. And yeah, if your tools that you want don't exist, he wrote a bash version control system, build it. If the tool doesn't exist, build it, irrespective of how much you think it's hard, start with something. A hello world, or just even something that prints out, we built step 1, we built step 2, we built step 3, something like that, build it, then iterate over time to improve your system. And who knows, when you open source it, we would use it. Thank you. Over to you.
So what do you use Zookeeper for?
Okay. Okay, so I'll answer them in reverse order. So Zookeeper is primarily for configuration management amongst all these services we have. Okay, I think there's a slide that didn't make it here. I was going to show the current infrastructure. I showed you the way it was when we started. So the current one, we have a lot of decentralized services and servers. So we use Zookeeper to manage configurations across all of them. That's what we use Zookeeper for. Then for how we manage updates, so each service is independent. So you could have, so it's even common now. If you have the OP app, for example, you discover that there are some features on iOS or features on Android, not on iOS. Now that is the case of, say, some features have been updated for the Android endpoints and not updated for the iOS endpoint. The updates are handled in such a way that for every time there's a feature change, you update a singular service, not the entire service. So you don't update the core backend that does your debit and credits, for example. You update probably the service that does only airtime top up. That's how we handle updates per time, and deployments are handled with Jenkins, and of course AWS Code Build handles most of our builds. So if there was a change, we have on-release engineers who do the releases for us for each of these changes that we're going to make. That's how we manage changes at the moment. Of course, we could improve it or change some things, but currently that's how we manage changes.
Do you have any
Okay.
So you mentioned you monitor you use tools to monitor maybe what's happening, maybe the instance of an OTP not being sent or stuff like that. So I don't know if you can mention it to me.
Okay, so when users make a request from their Android app.
Sorry. Please, how many questions do we have there? Let me count so that I know how. 1, 2, 3, 4.
Your question, how do we, what tools do we use to, from end to end, when the user comes to the platform and how he gets his request? Am I right? No, I didn't hear you. Please, let's.
Gateway.
Oh, gateway. Okay, so primarily we leverage everything AWS. So when you make a request from your app, it goes to a load balancer on AWS, and then that sends it to our backend services. That's not your question? That's your question. So from that backend, before applications gets deployed to that server, we have the developer who writes the code, pushes to, we use Bitbucket, pushes to Bitbucket, Jenkins fetches, builds the code with code build plugin and sends them to ECR. Then from ECR, when we deploy or say we are having a release engineer would pull the images, of course not manually, pull the images and deploy them on ECS, where those EC2 instances talk to. So your request coming from your OP app goes through the load balancer and comes to those servers that have been deployed to from ECR. Yeah, so what was the second question, please? Okay. So for the code itself, we use Prometheus for all the metrics. So like the example I gave, where we use OTP. So in our code, we instrumented counters to store some data in Prometheus, and then we view those data with Grafana, and in Grafana we set alerts for such notifications. So if you have too many failed OTPs, there must be something wrong somewhere, and we get a notification and then we act on it. If it's our own internal problem, we fix that. If not, we contact whoever we depend on to fix that problem. So that's how we do that. It's basically at the code level. There are libraries for Prometheus, Loki, and the rest in all the popular languages that you can leverage on. Okay, so next question.
I'd like to ask, aside containerizing your application, is it advisable to containerize your database? Because I think I read it somewhere that when the container crashes, your data stored in the database dies with it. So I just want to ask.
Okay, so that is, first of all, it depends on how you do it. You can containerize your databases, but you need to have volumes connected to those containers. So we have our DBs containerized, and we have volumes. So if anything happens to either the container or even the EC2 instance where the container is running on, if it crashes or for some reason something accidentally happens to that availability zone, our data is still safe. And then we can bring up a different server entirely and mount that volume and continue as necessary. So it depends on your use case, but it's possible to put DBs in containers. Just make sure you have volumes attached to them.
And Christian, bachelor's, continuous, so I want to know this the case when you are trying to get out, you can hear me. Okay, then regarding continuous build and deploy, I remember you mentioned a lot of tools. Okay, from GitLab, Jenkins, ECS, and EC2 instances. So I want to paint a scenario where you need to continuously deploy or push code to production, so maybe to solve an emergency issue, some prod, and then the build pipeline encounters maybe code break, maybe there's a breakage somewhere. How do you handle such a thing when it's a case of emergency?
Okay. Yeah, so in emergency situations, believe me, we had such scenarios where the pipeline just wasn't passing. So in a case where the pipeline breaks, what happens is there is some form of manual intervention where the release engineer will check out that your version and review it. Why the pipeline failed might not be because of what you wrote. It might be because of a dependency. So say for example, you're pulling NPM packages and NPM audit fails. Yes, so my backend that's supposed to process airtime has nothing to do with the front end NPM audit failing. So we review and we have a merge to a stable branch which is built and deployed. So the stable branch has its own tests, but there is a manual override for the test in case of emergencies. But in such cases, you clearly see a documentation of what was done so that when things are now fine, you can proceed as normal. But we have a manual override in code for such a scenario.
Okay, my name is Victor. I work as a cloud support engineer. And my question actually is more on a career path kind of thing. I'll speak for myself. I come from more of an infrastructure background, and I've grown to the extent that I can't exactly write code for application, like to build an application, but with the right comments and all, I can read someone's code and probably understand what it's trying to do. But I just want to know, like, for someone with that kind of background who can't exactly write code and applications, can that person still be a DevOps engineer? Or should that person be focusing more on being something of the SRE? So I just need to like draw a line between this, like, and just to like understand this better. Do I need to actually know how to write software, complete whole software before I can classify myself as a DevOps engineer or SRE and stuff?
Okay, that's a very valid question. We all face similar challenges at varying stages of our career. So I think yes, you can still be in DevOps sphere. You can still be in the SRE sphere. But a key thing you have to develop, like you saw in the slide, you have to learn to think like a developer, even if you don't develop immediately. If you had or ever witnessed a developer interview, for example, so you have a whiteboard interview, when they're asking you to write an algorithm on the whiteboard, they're not asking you to write the correct algorithm, they're asking you to show me how you think. So your thinking has to match this agile mindset we're talking about. You have to be willing to adapt. So even if you start off not knowing, you have to develop some form of consciousness of knowing what happens. So when we said there was a heap overflow or a buffer overflow, you have to understand what a buffer is, what it means to have an overflow. Even if you can write the code that corrects it, you need to be able to tell the guy who wrote the code that, young man, we need to correct this. So eventually, when you are skilled enough with the codes and you can pick up projects, I still like his example of that bash job that they wrote. It was not a case of writing a full Java program. It was a case of using what you know, how you think. You are already an infrastructure engineer, so you must have written shell scripts at some point in time or the other. That is programming. Programming is not necessarily until you use Java to write it before you program. So your scripts will do the program for you. So learn how to think in that mindset, and then if for some time in future you're able to pick up a conventional programming language, yes, you can then adapt to that, but by all means, you are in the DevOps society. I mean, literally everything we do now is software-based. All your infrastructure is software. So we might all as well all be software engineers, in quotes. So we live in an age where you cannot have ops who don't know how to develop and developers who don't know how ops work.
Ops works. Okay, one more question. I think there was one more person now. There's a question. I don't know, ask a question. Okay, that's the last question. David.
Hi, David. Thank you very much for your lecture. My name is Abraham from eWorker. Just really want to ask, from what you stated, you said you were using low-key, and I realized that moving forward, stop using low-key. I want to know the challenges, limitations, or reservations you had that maybe to abandon low-key.
Okay, yeah. We used low-key primarily for log monitoring. For those of us who don't know what low-key is, low-key allows you to do log aggregation. So when you store your logs in low-key, you can query what you stored as logs, say maybe by error tags or warning tags. You can do that with low-key, and you can give your code, your errors or logs labels that can help you easily filter. So that's low-key. So we used low-key at some point in time. It was awesome. I tell you, we didn't do a day without low-key. But then we had a few issues. For some reason, low-key's DB kept crashing on us. It uses a time series database inbuilt. You could also use S3 or whatever you will. But internally, it kept crashing. And then every time it started up, it wanted to load the full log file from generation to finish, and it broke every time it tried doing that. So when our logs were, say, maybe 100,000 or 200,000 or 400,000 lines, low-key was fine, could sort scale, but when we started going to 1 million lines, 4 million lines, low-key crashed every time we started it up. So we abandoned it for that reason.